In this video, I'll be working through the question you can see on the screen here from the summer 2025 Cambridge A-Level Maths paper 3-1. I'm going to try and show you how to do this question and not just the solution. So definitely pause, rewatch certain parts of the video as you need to. If you're looking for a different question from this paper or a different paper entirely, have a look at the description below. You should be able to find a playlist there, or have a look around on my channel. Okay, let's get into the maths. In question 3, we're going to be dealing with complex numbers. And I'd say this question is particularly tricky. I'm guessing a lot of students had difficulty with this one, even though most of you guys are probably pretty good at just dividing complex numbers or getting the modulus of a complex number. This question had a few extra steps to it. They didn't just want you to divide this, and it's not even written out in a normal way. They told you that this is real. This is an element of the real set. That means there's no complex part of this. So how does that help us? We'll leave this for a moment. We'll just deal with this idea over here. Now I can see there being probably a nice, interesting, smart way to solve this. I haven't looked at it too. I had a quick glance at it and I was like, I'm not sure I see it, but I'm sure there is a trick there. I'm going to do a little more brute force of a way. I'm going to, first of all, z is a complex number. So I'm going to rewrite z as z is equal, and you pick any letters you want. I'll use a plus bi. I'm going to write it like this, where a and b are just real numbers themselves. And I'm going to rewrite this whole thing here with this new numbering way. So instead of z, I'm going to write, let's put it all down here, a plus bi plus 5i. Instead of z in the bottom, a plus bi minus 5. And I'm going to rearrange this so all the real parts are together and all the imaginary parts are together. So what I mean is this top row will now become a is the only real part, and b plus 5 is the imaginary part with an I here. This is the same thing. On the bottom row, the a minus 5 are the real parts, and the bi is the imaginary part. So remember what they've told us about this. They've told us that this is real. I'm sorry, that's probably not, that's not what I meant to say there. That is important what I said. It's going to become useful in a minute. This is real, but I don't see how that obviously helps us yet. We can't just say like b plus 5 is 0. We'd be left with a divided by some imaginary part, and so it'd still be imaginary overall. So let's just go ahead and try and divide this out. I rewrote this up here just so I had a bit more room. And let me go over how to divide again, just in case you're unsure. I want you to remember that any number, think of this whole thing as a number. I won't draw a circle around it, it'll get a bit messy. But this whole thing here as just one number, and any number, whether it's complex or not, you can multiply by 1. So if we multiply any number, 5 by 1 is still 5, 8 by 1 is still 8, minus 20 by 1 still minus 20, 8i by 1 is still 8i. So we can multiply this by 1 if we want. Let me put that in, multiply by 1, because I'm going to do that sort of. The next trick is a number divided by itself is 1. 8 divided by 8 is 1. Minus 20i divided by minus 20i is 1. 8 plus 4i divided by 8 plus 4i is 1. So we're going to use that fact to, instead of putting 1 here, I'm going to put a minus 5 minus bi on top, a minus 5 minus bi on the bottom. Hopefully you remember this. This is the conjugate of this one. We've just changed the imaginary part of it, the sign of the imaginary part. But what I think a lot of students forget to realize is this is all 1. That's why we're allowed to do it. This is just the same number divided by itself. Why do we pick this one in particular? Why do we pick the conjugate? Because what we're going to see in a moment, when this multiplies this, all the i's are going to disappear. You don't have to multiply this out, by the way, if you know where this is all going. I'll multiply it all out just so everyone's on the same page. We can get away with just multiplying a small part of the top row though. So just to point that out. Let me go ahead and start multiplying things out then. Top row, real by the real, we get a times a minus 5. Real by imaginary, we get minus abi. Imaginary times real, we get, this is an important one, so I'll write all this out. I'll leave the brackets. B plus 5 multiplied by a minus 5. And that leaves an imaginary number. Sorry, this one's also important. And lastly, imaginary by imaginary. This isn't actually important. We'll just put minus b plus 5 times I squared. The bottom row. None of this is important. I'm just going to show you what we get. We get a minus 5 times a minus 5. I'll just write a minus 5 squared. We get a minus 5 times minus b, I. And we get b times a minus 5, I. These are just opposite. This is a minus b and a plus b. They just cancel. There is no I on the bottom row because we picked that. And we're left with minus b I squared. Sorry, I said there's no I. I squared is minus 1. So that just turns into a minus, which turns that into a plus. That just turns into a minus, which turns that into a plus. Remember what they told us about this whole mess. Let me rewrite it again. No, I won't bother rewriting it again, to be honest. Remember what they told us about this whole mess. They told us it's real. Going back to the start, they told us the division part is real. This is real. This is real. That means there should be no i's in this whatsoever. We got rid of the i's on the bottom row. We did that. We're left with these i's up here. They're telling us it shouldn't be there. It should be 0. Everything on the top row with an I should be 0. So I can write minus AB, this part, plus B plus 5 multiplied by A minus 5. All of this must equal 0. It must add up together to get 0, to get all the I's gone. And we can clean this up a lot here. We'll get minus AB plus AB, this is B times A here. Minus 5b plus 5a minus 25 equals 0. The ab's cancel. We're just left with, divide everything by 5. We're left with an a here, minus a b from here, and a 5 here. I've divided everything by 5 and I've moved it over. We get this out of this fact. The fact that this is real tells us that. You didn't have to do all this work. You could have, once you got to this line, you could have just we could have wrote this top row. And even at that point, you could have just said, the only thing I'm interested in is A multiplied by minus BI and B plus 5 multiplied by A minus 5, which I finally did up here. You could have jumped a lot of that. You could have saved yourself a lot of work here. This is not enough to solve. We still don't know what A and B is. They want us to write out, oh sorry, they've used X and Y. my apologies, I should have used X and Y the whole time. I'm sorry, I'm sure you can get over that fact. We still need to use the fact that Z, the modulus of Z is equal to the square root of 17, or A, I'll stick with my A and BI. A plus BI, the modulus of this is equal to 17. Remember how the modulus works, that's just A squared plus b squared, or the square root of that is equal to the square root of 17. That's just a squared plus b squared is equal 17. We have these two simultaneous equations. I will clean the board off now and we'll solve this, but hopefully you're all able to solve this at this point. But yeah, we're just down to a quadratic simultaneous equation. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. Okay, let's go ahead and solve it then. Let's just rearrange the first row so we have A is equal B plus 5. We could have also got B is equal A minus 5. Makes no difference really. Once we have this on its own, we can easily change this to A squared is equal B plus 5 squared. Now we have an A squared here that's independent of this line. we'll combine them. Well, let's write this line again. I'll show you what I mean. Instead of a squared, we're going to write that. B plus 5 squared. But I'm writing this line. I'm just, instead of a squared, I'm putting this in. Plus b squared equals 17. We've got an equation with only one unknown. We're going to get a quadratic, but still, we're nearly there. Let's clean this up. We'll get b squared here plus 10b. That's 5 times b and b times 5. Plus 25 plus b squared is equal 70. And let's clean it all up. We get 2b squared plus 10b plus 8 is equal 0. Oh, we can clean that more. Divide everything by 2. B squared plus 5b plus 4 is equal 0. Let's hope this is comes out evenly. It does, thankfully. We have b times b. Two numbers multiplied to get 4 and add or take away to get 5. That's 4 and a 1. They will all be plus. So our two answers here would be b is equal minus 4 and b is equal minus 1. Should we be surprised to get two answers? Read the question. It says give your answers. There's an S at the end there. It's a plural. So we knew we were going to get more than one answer. So you should be on the lookout for that. This is not it. So many students leave this as their final answer and throw away 1, 2 marks. I think the examiner has to throw away if you've only leave this. They want A. We found B. We still need A. A minus 4 is equal 5. That's this first line here. A take away whatever B is equal 5. That's A plus 4 equals 5. A is equal 1. These answers go together. Remember what they should look like. 1 minus 4i. That's this is z. Remember, z was equal. Let's write it up here. Z is equal to a plus bi. Or if you had read the question better than I did, z is equal to x plus yi. Either way, this is the answer they were looking for on this part. On this part, a minus 1 is equal 5. A will equal plus 1 will equal 4. Combine them, 4 minus I, minus 1i. These are your two answers to question 3. Okay, that's it. If you have any follow-up questions for this, or you see any mistakes I made, let me know in the comments. Do me a favor, tell me whereabouts in the video you're talking about. It helps me answer you. Thanks for watching. Have a great day.